So we're going to talk about blood pressure, and we need to understand what pressure even is. Okay, so what is pressure? Well, pressure is a force applied to a surface. So, in blood pressure, we're talking about blood is the force, the movement of blood in the vessel. There's a force from the blood on the walls of that vessel. Okay, so pressure basically is a force on a surface area. And we measure that in millimeters of mercury. So when we say a force on a surface area, the force on the same force on one area may be different than that same force, or the pressure from a force on an area may be different than that same force on a different area. Okay, and what I mean is if you have, let's say you step on somebody's hand and you're wearing your tennis shoes. Okay, so you're standing on somebody's hand in your tennis shoe, and your tennis shoe, is flat. It's just a flat, thing on your hand, and the sole of the shoe, of the tennis shoe, is going to hit a pretty decent surface area of your hand, unless you're just kind of sitting off the tip of it or something like that. But if you're on your hand, there's a good amount of your hand being touched by that sole of the shoe with the force. And yeah, it may hurt, may not feel very good. But what if you got stepped on your hand by the heel of a stiletto shoe? Okay, so a heel that has a little pointy thing, and that point is right on your hand, same person, same weight, same force. Is it going to hurt more than that person stepping on your hand in the tennis shoe? Okay, yeah, it's going to hurt more because there's that force, even though it's the same weight, it's being concentrated into this little tiny area. Okay, so the force or the pressure you feel is more. Okay, so that's what I mean by force over surface area. So when we talk about blood pressure, again, we're talking about the measurement of force applied to vessel walls. Okay? So if we have a constantly low blood pressure, or we have basically what's called hypotension, what does that mean? What are we going to have from that? So in hypotension, where the blood pressure is low, so there's not as much force being applied by the blood onto the walls of the vessel. So you're going to probably have, if it's way too low blood pressure, you're going to have low perfusion. So what does that mean? It's going to mean decreased capillary exchange. Because when blood is going through the capillary, it is pressing against its walls and it's pushing things out. Okay? So if there's not a lot of pressure there, there's not going to be a lot of push. So there's not a lot of stuff that's going to be able to leave the vessel. If you have high blood pressure, that's hypertension. Then what do you have? Well, that will cause things like vessel damage. Vessel damage creates inflammation. Remember, in any kind of, quote, injury, inflammation sets the stage. And inflammation that's chronic in the vessels causes cardiovascular disease. So basically, you're going to form plaques on the walls of your arteries trying to heal the damage. So we need to talk about blood flow with this. So blood flow. So the flow of blood follows a pressure gradient. Follows a pressure gradient. And we've seen that before. We've seen the movement of something with its gradient. And we were looking with solutes, which we've studied before. Solutes move passively with their concentration gradient from high to low. So high concentration to low concentration. If we add energy, we can force them to move from low concentration to high concentration. Okay, but that's the gradient. Blood flows the same way, and it flows through the pressure. So it follows a pressure gradient from high pressure zones to low pressure zones. All right. And if you think about it, the blood starts going to the systemic circulation when it goes into the aorta. If you have a blood pressure of 120/80, then that systolic, that pressure from the contraction of the ventricles is causing the aorta to be in a pressure or be at a pressure of 120 millimeters per mercury. And then it shoots out into the systemic circulation and it goes to the different vessels. And as it moves and goes to the different vessels, goes to different parts of the body, by the time it gets to the capillary bed, that pressure is way down. It's down to about 35. Okay, so the blood is moving toward with that pressure gradient where it starts at 120 and as it moves along, it's going down, 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 down. So another aspect of this is resistance. So resistance is going to have an effect on the pressure number. So resistance, what is it? It's the opposition to blood flow. Basically friction. So as the blood is moving down the vessels, it's rubbing up against the wall, and that's a friction. Okay? If you've got plaques in your vessels, that's more friction. That's more stuff it's got to get by. Okay? So the higher the friction, the more effect it's going to have on the movement of the blood. All right. So how does the pressure gradients form? They form from the heart. So the heart creates the pressure gradient. The heart's pumping forms the pressure gradient. Okay, so when we looked at the heart and we looked at the cardiac cycle, we looked at systolic or systole and diastole. Okay, so as far as pressure goes, the way we talk about the pressure of those circumstances is within systolic pressure and diastolic pressure. Okay, so systolic pressure is the amount of pressure in the aorta, so the amount of pressure in the aorta during ventricular systole. So during ventricular contraction, where the blood is being injected into the aorta. Diastolic pressure is the amount of pressure in the aorta during ventricular diastole. Okay, so the diastolic pressure number, which is the lower number, is really the most important number, because the higher the pressure you have during relaxation, if it's really high, that's a bad thing. That means that there's high pressure, there's something going on there that's chronic, that's happening all the time. Okay, so usually that lower number has a more of a telling of more information about the vascular health of someone, really, than the systolic pressure. All right, so now we're going to talk a little bit more about pressure in the next video.